Assalamualaikum and greetings. Welcome to our presentation. Our research falls under the Life Sciences category.
Let us first start by introducing ourselves. My name is Imran and I'm the leader of the team.
Hello everyone, here is the most passionate team member, Fathul Amar bin Adham.
Hi, I'm the creative member Uwais Alqarne bin Zainuddin.
The title of research conducted is RoboRoach, controlling the locomotion of cockroaches through external electric impulses.
RoboRoach is a project to control the locomotion or movement of cockroaches using external electric impulses. By mimicking the control mechanisms and physical structures of natural biological systems, engineers are able to design mechanical robotic systems to improve their performance.
Firefighters rescue victims easily when they are at the specified gathering location during a fire. However, sometimes victims panic and they scatter around the location. Firefighters will take time to identify the whereabouts of the victims when they are not gathered at the specified location. Thus, we need help from another assistant to solve this problem and save up some time.
The objective of our research is to develop a solution to reach victims in unreachable places and also to identify a more eco-friendly and cost-efficient alternative to drones.
So why do we use discoid cockroaches? Well, number one is because it has a high payload and resistance. This translates to heavier components and as such better equipment. Number two is because it is very easy to care. They are not very choosy in their diets, which means studies could be conducted more easily. This brings us to our next point, which is they are heavily researched. Due to the factors mentioned before, the cockroaches are very easy to care, which means there are multiple other researchers about discoid cockroaches. Lastly, it is because they breed very quickly. This means the likelihood for supplies depleting are very low.
Here are the uses of RoboRoach. First, RoboRoach can be used during search and rescue operations. Second, RoboRoach can be used to identify victims during a fire incident. And lastly, third, RoboRoach can be served as a courier to locations unreachable by human beings.
Because of its high availability and resistance, American cockroaches are used for this project. However, Blaberus discoidalis cockroaches are preferred because of its larger size and payload. The cockroach's movements are restricted as per our program. We may place some kind of compartment on it as long as it does not hinder the cockroach's movement. We will use a mini camera in cases like fire rescues or even investigations.
In this situation, the house is on fire and there's a victim trapped in there. But the firefighters don't know where he is located. Hence, this is the time for RoboRoach is being used properly. And by using this way, we can save up the rescue time. As you can see, the RoboRoach is searching every corner of the location to make sure all the places empty and there's no victims left out. As you can see on the program controller, there's a view of RoboRoach mini camera and Bluetooth tracker for tracking its location. When the victim's location is detected, the firefighters are ready to rescue.
Here are the RoboRoach specifications. We need an Arduino Pro Mini, silver wire, male pin header, Bluetooth low energy beacon, lithium polymer battery, and a wide angle camera.
Let's go deeper into the research methodology. Since we are using a living cockroach, the cockroach is being immobilized by putting it into a cooling agent such as dry ice. This step is necessary to make sure that the surgery is going easier and smoothly.
The basis of the second step is to set up the electrodes using electric components. Firstly, a male pin header was cut into 3 pins. The silver wires will then be soldered into the male pin headers.
This is the highlight of our methodology. The RoboRoach is taken out from the cooling agent. Then its antenna is cut around 50% of its original length. The cockroach's pronotum is smoothed with sandpaper to ease the pasting process. The header is pasted onto the cockroach's pronotum with glue. A hole is made at its thorax by using a needle. One of the 3 wires is attached to the thorax while the other 2 is attached to its antenna.
Cockroach back surface is smoothed by using a sandpaper. Then the program Arduino Mini Pro is placed there. Hence, it is connected to the previous electrode setup. As you can observe, the electrode is attached to the first pair of legs thorax, which is prothoracic ganglion. By attaching the electrode to prothoracic ganglion, it has the highest rate of surgery success. After the surgery done, the extra component such as mini camera and Bluetooth tracker is chosen for specific mission. Every research has its own pros, and for our research, there are some advantages. Firstly, as we know, cockroach is very abundant around the world and also biodegradable, so less pollution. The next one is the project is cost saving for third world countries. Lastly, RoboRoach is easy to manufacture because the electrical components needed are very common.
In conclusion, RoboRoach could provide an alternative for drones. It may not replace it. Drones are far easier to maneuver compared to RoboRoach. As a signatory to the Paris Agreement, Malaysia has committed to reducing 45% of its greenhouse gas emissions by 2030. This agreement means we need as much help as needed to reduce our carbon footprint by 2030. RoboRoach is also biodegradable, which means losing it will not have as much environmental impact compared to drones. Cockroaches also breed quickly and easily, resulting in a consistent neuroanatomy amongst each other. Therefore, we believe RoboRoach could help to deliver a cheaper and greener option for drones.
These are our references. These references assisted us in our methodologies and conclusion.
And last but not the least, we want to thank you all for listening. Without your continued support, we would never be able to put on competition like this. So, thank you very much. Bye!